Infinite geometric series are series that go on and on and on and on forever, just like a repeating decimal. So convergent means that all the terms in the sequence are going to go towards a constant value. So that means they're going towards 0 or a repeating decimal or something. Divergent means they're not approaching a constant value. So if they're getting increasingly larger or increasingly smaller with no bounds, then it's divergent. When you're checking to see if a sequence converges or diverges, you test it with -1 is less than r and less than 1. So if r falls into this, then it converges. So for the first example, it says predict whether each infinite geometric series has a finite sum and estimate the finite sum. So we have 1 over 3 plus 1 over 12 plus 1 over 48 plus 1 over 92, ... So to find r, you go 1 over 12 divided by 1 over 3. And you should get 1 over 4. 3 over 12 is 1 over 4. So since -1 is less than 0.25, which is less than 1, we know that this converges. So it's going to go towards a point. So that means if you were to imagine the graph, it's going to increase, and then it's going to get to a certain point, and it's going to keep going towards it, like this was an asymptote almost. So to do this, to find our estimate our sum, we're just going to see what our sums are and see what they seem to be going towards. So sum of 1 would equal 1 over 3, which is 0.333. Sum of 2 is equal to 1/3 plus 1/12, which is 5/12, which is 0.416. Sum of 3 would be 5/12 plus 1 over 48, which is 7 over 16, which is 0.437. And as you can see, if we were to do our last one, 7 over 16 plus 1 over 192, you get 85 over 192, which is 0.442. So they are all going towards 0.4 repeating. So this would be an estimate of our finite sum. So you can have an infinite series, but all your terms can go towards one finite sum, so one thing. So for the next one, r would be -8 divided by -4, which is +2. And because it does not fall into this doesn't work, that means it diverges. So it keeps getting increasingly negative, so a way that this graph would look was it would go down and down and down and down in a straight line. So for this one, 1 over 100 divided by 1 over 10 is equal to 1/10. And since -1 is less than 0.1, which is less than 1, we know that it will converge. And the graph will go towards a point. So now we need to figure out what the finite sum would be. So sum of 1 would equal 1 over 10, which equals 0.1. Sum of 2 is equal to 1/10 minus 1 over 1,000, which equals 9 over 100. 1,000, that's 100. 9 over 100, which equals 0.09. Sum of 3 is 9 over 100 plus 1 over 1,000, which is 91 over 1,000, which is 0.091. I don't know why I added a 1 there. And sum of 4 would equal 91 over 1,000 minus 1 over 10,000, which is 909 over 10,000, which is 0.0909. So all of them have this 0.09. So your finite sum that they're going towards is 0.09. Repeated. So the equation for the sum of an infinite series is T1 over 1 minus r. And this is only if it converges. So when negative 1 is less than r, less than 1. So first we check to see if it converges. So for the sequence 32 plus 8 plus 2 plus 0.05, 8 divided by 32 is 1 over 4. Since negative 1 is less than 0.25, which is less than 1, we know it converges. So the sum of infinity is equal to 32 over 1 minus a quarter, which is 32 divided by 3 over fourths, which would be 4 times 32 divided by 3, and you should get 42.666666 repeating. So this is the sum of the series. 42 plus 6 to infinity. And beyond. So for the next one, T1 is equal to 100. R is equal to negative 10 divided by 100, which is negative 1/10. And because negative 1 is less than negative 0.1, which is less than 1, it converges. So we plug it into our formula. The sum to infinity is equal to 100 over 1 minus negative 1/10. So that's the same as 100 over 11 over 10. So 100 times 10 divided by 11, and you should get 90.90909090. So the 90 repeats. So this is the sum. 90 and then 0.90 to infinity. For the next example, we have 0.16 repeating. The 6 should have the line over it, not the 1, just the 6. So that means our sum of our series would be 0.16 repeating. So we want to find a fraction that's equal to that. So if we were to write this, 0.16 as a series, we do 0.1 plus 0.06 plus 0.006 plus 0.0006, and it would go on and on and on like that. This one stays the same, this 1/10. It's not part of the repeating. But this 0.06, which is the same as 6 over 100, this continues on going. So our T1 is going to be 6 over 100. We're just going to leave this for later. Our R will equal to 0.006 divided by 0.06. So the second term divided by our first term, which is 0.1, which is 1/10. So we're going to plug this into our equation. So the sum of infinity is equal to 6 over 10, 100, divided by 1 minus r, which is 1 over 10th. And we know since 0.1 is less than negative 1 and positive 1, that it is a converging series. So we know it's going towards 0.06. So we're going to solve this as a fraction. So this would be equal to 6 over 100 divided by 9 over 10, which is the same as 6 over 100 times 10 over 9. And we want to leave it as fractions because we're trying to find our number as a fraction. So if you do this, you should get 60 over 100, which is the same as 1 over 15. So that means that the sum of all of this is 1 over 15. Because we have a 0.1 that's not repeating, we need to also include that in our fraction. So our final fractions of 0.16 repeating will be equal to this fraction. Oh, I put a 0. 1 over 10 and this fraction. So 1 over 10 plus 1 over 15, and you should get that to equal 1 over 6. And if you take your calculator and you type 1 divided by 6, you should get 0.166666666. So that's how you take a repeating decimal and turn it into a fraction.